Hello, 8th grade math students. Mr. Lawrence here, and I made this video for you to help you get ready for the test. Yes, we're getting ready for the test. Anyway, here we go. Are you ready for the Topic 10 test? There are going to be 4 sample problems, things you're going to have to be able to do on Wednesday. So number 1 says to perform a dilation with a center at the origin and a scale factor of 3. So you're going to perform it on this rectangle. Are you taking notes on this? You should have your notebooks out. And you should be doing this problem with me. You're going to need graph paper for it. You're going to need some straight edges, okay, or the best you can. Now, problem number 1, dilation. Yes, dilation with center at the origin. This means I'm going to need coordinates. So I'm going to write down the coordinates of points A, B, C, and D. And it looks like they're in this lovely orange color. So coordinates of A are located at 1, 2, 3. Looks like 1, 3. The coordinates of B are located at 2, 3. The coordinates of C are located at 2, 0. And the coordinates of D are located at 1, 0. All right, now like I said, you should be doing this with me. So you should have this rectangle graphed at those coordinates. If you don't, pause the video and then go ahead and get it graphed. Okay. So now, I need to perform a dilation with a scale factor of 3. Since the center is the origin, did I say that enough? The center at the origin, that means I'm going to multiply each coordinate by 3. So 8 prime is going to become 3, 9. How did I get that? 1 times 3 and 3 times 3. B prime is going to be at 6, 9. Okay, C prime. You tell me C prime. Go ahead. Come on, Desiree. I know you can do it. Go on. Yep, that's right, Desiree. It's going to be 6, 0. Okay, and D prime. Oh, Emma. I know Emma can do this one. All right, Emma, if I multiply both coordinates by 3, I'm going to get 3 times 1 and 3 times 0. So now I'm going to plot these points. So A is at 3, 9. So A is going to go to 1. We'll start at the origin. 1, 2, 3. And all the way up here to 9. So there is A prime. Okay, B prime is at 6, 9. So if this is 3, 9, then I'm going to go 4, 5, 6, 9. So there's B prime. Hey, one thing I like about it, AB was 1 unit long, scale factor was 3, and look at this, A prime, B prime is going to be 3 units long. Coincidence? I think not. Okay, C prime. C was at 2, 0. C prime is at 6, 0. So 2, 0, 3, 0, 4, 0, 5, 0, 6, 0. Ooh, it matches up perfectly with B prime. Look at that. And that would be this side, yes. Okay. That would be from here to here. Just like that. Right? I guess I should draw them all in like that. There we go. That's looking better. All right. Now, again, side BC was 3 units long. I'll bet you this one's 9 units long. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then D prime goes to 3, 0. And so that should be right here, 3, 0. And I better draw this other side. Right? And I could draw this one too. It's sitting right on the x-axis. So, in your notes, please write down, if you haven't already, when the dilation center is the origin, I multiply the coordinates. Yeah, do you see that? I multiply the coordinates. All right. Problem number 2. I have to perform a dilation with the center at a point P. So this one's done a little differently. And a scale factor of 1/2. Okay, well, point P is a special point in this one. You see, P is not going to move. So I don't need the coordinates of all the vertices. I don't need to write P, Q, R, S. I can if I want to, but I don't have to. What this means is, since scale factor is 1/2, I'm going to multiply the length of the side here by 1/2 and the length of this vertical side by 1/2. So let me see, how long is this horizontal side? Well, it goes 1, 2, 3, 4, 5, 6. Well, 6 times 1/2 is 3. So the new side will only be 1, 2, 3 units long. And notice it comes right from point P because P doesn't move. Why not? Because P is the center. And so that would go like that. Now similarly, I'm going to do the same thing to the vertical side. The vertical side is 1, 2, 3, 4 units long. Okay, so I'm going to take 4 times 1/2, and there I'm going to get 2. So it's only going to go to here. All right, so it's going to look like this. Okay, now I know I'm drawing a rectangle because these shapes are similar, and so this other horizontal side will have to be the same length as the one above it, and similarly the right hand vertical side will be the same length as the left hand vertical side. So when you have a scale factor of 1/2, the shape's going to get smaller. You're going to multiply by 1/2, which of course is the same as dividing by 2. If it was 1/3, you'd divide by 3. But when the center is a point, that point stays put, and then everything gets moves toward that point or away from that point. Like, for example, let's say I had this rectangle here. Okay, and let's make it just a simple 1 by 2 rectangle. And I was going to do a dilation. Let's do a scale factor of 2. Okay, this one I'm just making up on the spot. This will have a scale factor of 2. And it's going to be around point, I don't know, T. Okay? Well, I want you to pause the video, graph this here on a graph, and then see if you can do it. Okay? So if you're still watching, it means you haven't done it. Please pause the video and do it. And then unpause the video and watch my solution. Okay, here comes my solution. So, since T is the center of this one I just made up, T will not move. Now this horizontal side here is 1 unit long. So I'm using a scale factor of 2. The new side will be 2 units long. How did I get that? 1 times 2. And very similarly, the vertical side here on the left is 2 units long. Well, scale factor of 2 means it's going to be 4 units long, and so this new side is going to go like that. Okay, I need the corresponding parallel sides, and there you go. All right, so when it was at the origin, like in this problem, we had to multiply all the coordinates by the scale factor. So when it's centered at the origin, you multiply the coordinates by the scale factor. But when the center is a point, that point stays put, and the sides get longer or shorter by a product of the scale factor, meaning you multiply the side by the scale factor. 1 times 2 is 2. 2 times 2 is 4. Or in the original one, we had 6 on this side. The scale factor is 1/2. Oh, excuse me, I'm so sorry. And so I multiply 6 times 1/2 and I got 3. And the vertical side was 4 units long. 4 times 1/2 is 2. Okay, moving right along. All right, so now I have to describe a rigid motion followed by a dilation that maps triangle ABC to triangle A prime, B prime, C prime. Okay, now here's where I make my little notes. Okay, first of all, I notice that a reflection has taken place. How do I know? That the triangles are pointing 2 different ways. See that? B is pointing to the left, B prime is pointing to the right. There's definitely been a reflection. Okay. Also, I'm going from ABC to A prime, B prime, C prime. So I'm going small to big. And so small to big, the scale factor looks like it's going to be, well, let me see, this vertical side is 2, this vertical side is 1, 2, 3, 4. Looks like the scale factor is 2. Now, to get this right, I'm going to start backwards. I'm going to start with the black triangle, the larger one, and I'm going to work backwards. And to go backwards, the first thing I'm going to do is undo the scale factor. All right? Now, since none of these points line up with each other, I'm going to assume that it was centered at the origin. So I'm going to do a dilation. Okay? I'm going to use a scale factor of 1/2 because I'm going big to small, and I'm going to center it at the origin. And so when I center at the origin, that means that A prime is at 2, 1, 2, 3, 4, 5, 6, so 2, 6, right? B prime is at 10, 2, and C prime is at 2, 2. Okay? Now, I've got to multiply by the scale factor all these coordinates. Why? Because the dilation is centered at the origin. So I multiply them all by the scale factor of 1/2. And so I'm going to get 1, 3. And then for B double prime, I'm going to get 5, 1. And then for C double prime, I'm going to get 1, 1. Okay, so C double prime is going to be there. A double prime is going to be here. C double prime. And then B double prime is 3, 4, 5, 1 right there. Okay, now I'm really liking how this looks because the green triangle that I'm drawing in freehand looks congruent to the blue triangle, except it's oriented the wrong way and looks like a reflection. So now I'm going to reflect the green one across the y-axis, right? Okay, yeah, because it's 1 unit from the mirror on the right, the blue one's 1 unit from the mirror on the left. To get my actual answer, my solution, this is backwards. I have to go forwards. So I'm going to start with the reflection. So my actual solution, step 1, is to reflect triangle ABC across the y-axis. My second move is going to be to dilate with a scale factor of 2. Why is it 2? Well, backwards it was 1/2, right? I need the reciprocal of it. And center at the origin. And there you go. That will transform the blue one to the green one, and then the green one to the black one. Exactly. Piece of cake. All right. Okay, here comes the last problem. It says find 2 different sets of coordinates that would make triangle XYZ congruent to triangle ABC. So let's take a look at it. Here's AB and here's C. Now, I notice right off the bat that triangle ABC has a base, side AB, of 1, 2, 3, 4, 5, 6 units long. Okay, well, XY is 1, 2, 3, 4, 5, 6 units long. So, for this to be congruent, okay, I'm going to need my point Z to be the same distance from XY as C is from AB. So this is 1, 2, 3, 4 units. I could go 1, 2, 3, 4 units. That is one possible place for Z. So I'm going to do point Z, and it's going to be at 1, 1, 2, 3. Coordinates 1, 3. That is one possible answer. A second possible answer for Z would be if it was pointed down the other way. So it could go from here and go down 4. We go 1, 2, 3, 4. See, that's another possible Z answer there. And that Z would be located at 1, 5. If I count down, it would be 1, and 1, 2, 3, 4, 5. Okay? Now, somebody might be noticing that, hey, we might have been able to do it over here. Well, that's possible. You could make it congruent if you did that. So it would be slightly different because A is going to B and then B is going to C. It would be slightly different because the diagonal would be BC, but the triangles would be congruent. So if I also could have gone here or here. But the direction said I only had to give 2 coordinates. Okay, so here's what you need to do. The video's over. You can go back and rewatch part if you need to. Hopefully you took notes and did these problems with me. If you didn't, you definitely need to go back and do it. Now you need to begin the review assignment. All right? Do the best you can. If you need to come see Mr. Lawrence at Pride Time, come get a pass from him. Don't send him an email. He won't be able to check email for a while. All right? But you go ahead and you can stop the video and get onto digits and do the review assignment. All right. Good luck to you all. Mr. Lawrence signing off. Have a good night, everybody.